all the terms of prisms here. So we're going to start off by talking about the surface area of a prism. So I'm going to abbreviate surface area with SA. Is that okay for you guys? Yeah. Okay, so surface area of a prism. Okay, let's draw the basic prism here. It's going to look something like this. So yeah, do your best to make it three-dimensional of what you can't see in the back. So here's a regular old right prism. Okay, so here are some terms that we're going to use. Prisms have two bases. There's a base on the top, and there is a base on the bottom, underneath, right there. So we have two different bases. Okay, they are parallel to each other for a right prism. The height is what you'd expect it to be, just the actual from floor to ceiling. And here's some two new words. If you take for instance, just this front side here that I'm going to paint in yellow. Okay, this front side, this is a face. This is one of the faces of our prism here. And this is called a lateral face. A lateral face or a lateral side. Okay? So how many lateral sides does this prism have? It has 4. Yeah, it's everything except for the bases, right at the top and the bottom. And the other new word that we've never heard of before yet is this piece here. And there's quite a few of these. I'm taking the one in the back, and there's another one right here. Okay, these are called lateral edges. All right, so lateral edges. So these are all the new words we have. We have the height, we have the bases, we have a lateral side or a face, and we have a lateral edge. That's everything for a right prism. But what about if you have a slanted prism? So something that looks like this. So do your best to draw this slanted prism. Okay, so it's kind of a prism that's sort of leaning over to the side a little bit. Kind of difficult to draw, but still we have the same stuff. We have a base for the top part. We have a base for the bottom part. So we're just dealing with the words here. Okay. We have a height, which is floor to ceiling vertical. So our height for this part is floor to ceiling vertical 90 degrees. We have a new term, that's this piece over here, that's called the slant height. And we're going to deal with these throughout the unit. So we still have a lateral face, if we wanted to call it that, but the new term in there is a slant height. I wanted to tell you the difference, or point out the difference between a slant height versus a regular height. Okay? Then I'm going to talk about the difference between surface area, same idea, same box here, versus lateral area. How many of you ever wrapped a present for Christmas for somebody else? Okay? So think of surface area as total paper all the way around the box of the gift, okay? So surface area is total area of all faces. Okay, that's going to be our regular definition for surface area. The total area of all the faces added up around the whole figure, okay? So if that's what surface area is, then what is lateral area and why is it any different? This is all faces except the what? The bases. Okay? So if it wants the lateral area, that means it only wants the actual sides of the box, right? Or of the prism, whatever it is you're working with. So all faces except the bases. So that's the lateral area of what we have. Okay? How's everybody doing so far? Is it making sense to you? Can I answer any questions or clarify any terms for you? We're all good? For sure? Okay. Okay, next, let's do a little quick example. Let's draw yourself a right prism. And we're going to find the surface area. Find SA. And we're going to find it sort of instinctively. Then we're going to take a look at a formula that can do it for us. So, finding a surface area. So, here's my prism. Or what I have here. Okay, straightforward. And I know some information about this. I know that this front piece is 3 inches. I know this back piece is 5 inches. And I know this height is 8 inches here. Okay, so if we were going to wrap this up, right, in paper, let's start with the bases. How many bases are there? There's 2 bases, right? So I'm going to have 2 bases. And what is the area of each base? It is 3 by 5, right? So that's going to be 2 times 3 by 5. Oh, I don't know. Whoa, I don't know what I just did. 3 by 5. All right, we're all still there. So that takes care of this bottom base here and this top base here. There's 2 of them because there's a top and a bottom, and each one is 3 by 5. We're going to add to that. How many sides over here do I have? This side box over here and the one on the other side. So that's going to give me 2. What's the dimensions of that piece? Add that up. So there's 2 of those. And that's 5 by 8. You guys still follow along with this? Okay. So I've done this. What's the only side I have not yet done? The front part and this side in the front. This sort of this piece right here, and then the one in the back that we can't really see. And what's the dimensions of that piece? 3 by 8, right? And how many of those do I have? So I'm going to add 2 times 3 by 8. Okay, you guys have calculators. I don't have one in front of me. So I need some calculator help. There's going to be 2 times, well, how much is 3 times 5? I know that one. That's just 15, isn't it? Okay, plus 2. 5 times 8. I even know that one. That's just 40, isn't it? Plus 2 times 3 times 8. Hey, I even know that one. That's 24, huh? So that's going to be 30 plus 80 plus 48. Okay, please add that up and tell me what you get. How much? Can I have 3 people verify that's 158? 1, 2, 3, 4, 5. Okay, so we have 158 what, though? How do I say the units? Inches squared, because we're dealing with area. Yeah, very good. Inches squared. This is easy stuff, right?
It's going to get so much harder?
No, it's not so bad.
2 boxes, you're going to add a bunch of random.
No way. Okay. Yeah, okay. We're going to go talk about theorem 12.2 on the toolbox. Okay, so head over to your toolbox. Toolkit, sorry. Thank you. Toolkit. And this one's already done for you. Is that correct? I put this down. All right, let's head back over here. And that was the whole 3rd box. It's pretty easy, huh? So for the 4th one, we're going to do another example together. And I'm going to give you I'm going to give you this prism here. All right. Now, just because this one is laying down a different way doesn't mean that it doesn't have a base, right? So where are the 2 bases on this thing? The left and the right. Yeah, the 2 triangles. Yeah, exactly. So this is going to be 7 inches here. That side is 7 inches. This side is 7 inches. And this side is 7 inches. So what type of triangle does it make that? Yeah, it makes this whole front base here, this base, an equilateral triangle. So it's the same as that one in the back there, too. Okay? And the other thing that we know about this is that its length is, what did I say it was? My notes, I think it was. Its length was 5 inches. Yeah, let's make it 15. That makes more sense, huh? Okay, so according to our new theorem then, we're going to have the surface area is going to be equal to 2 times B plus PH. Is that what it says? Yep, 2 times B plus PH. Good. Okay, so the surface area is 2 times. Okay, now we need the area of the base plus pH. What is the area of a base? How many of you remember the area of an equilateral triangle from last unit? If this is S, and this is S. Yeah, very good. It's S squared, square root of 3 over 4. Very nicely you're done, remembered. So that's going to be 7 squared, square root of 3 over 4, plus pH. So 2 times 49, square root of 3 over 4, plus. Now, P stands for the perimeter of the base only. And if the base only is a triangle, then the perimeter of that triangle is just 7 plus 7 plus 7, which is how much? 21. 21 times, what's the height? 15. Very good. Okay, so we have calculators out there. So our surface area has to be 49 square root of 3 divided by 2, because the 2 cancels out with the 4 to make a 2 down here, plus whatever 21 times 15 is. So I'll figure out 21 times 15. You guys figure out the front part. 315. Okay, someone help me out. What is 49 times the square root of 3 all divided by 2? I have 2 people that say 21.2. Can I have other people verify that? Yeah? 21.2? Can I have one more person verify that it is 21.2? You have a calculator? You're doing it? You got 42.4. Uh-oh. Looks like we better check it. Okay, 3 square root times 49 equals divided by 2. That gives us a 42.4. Huh? No, it's not divided by 4. It's divided by 2. Yes. Okay. Yeah, because look, right here. Doesn't the 2 cancel out with the 4 to make that a 2 down here? Well, yes. That's what I want to do. So I'm going with 42.4, okay? So S is equal to 42.4 plus 315. So the surface area would be, if we add that up, 42.4 plus 315. Can we move past that, please? Thank you. It's 357.4. 357.4, and we're calling this inches squared. And this is theorem 12.3. I've written it on my toolkit. I'd like you to write it on yours. The surface area for a right cylinder. So basically, surface areas of Coke cans, surface area of soup cans, surface area of Clorox disinfectant wipes. Ew, they're leaking all over my desk. So we just put theorem 12.3. Ooh. What just happened there? I'm on the wrong site. Hold on. I want to be on this one. There we go. Okay, so we just put 12.3 into our toolkit. Our last idea here is going to be the surface on an iced tea can here, okay? All right, so we're going to figure out of this. I have a. Do you guys think this? I mean, can. Is this can, right? What? No, it's the same size. That's the same thing. All right, we did some measuring just now. It was kind of fun, and we found that this was 6.2 centimeters. Is that right? And then this was how many centimeters? This was 19 centimeters. Okay, so you are an artist, and you're working for the Arizona Iced Tea Company, and you want to figure out how much area you have to design the logo for the iced tea can here. So we said the surface area of a cylinder, we're going to use this formula here, right, is going to be 2 pi r squared plus 2 pi rh. So that's going to be 2 pi r squared plus 2 pi rh. So it's going to be 2 times 3.14. What's the radius of this thing? 3.1. Very good. Squared. Plus 2 times 3.14 times the radius, which is 3. Because it is the radius, right? Half of 6.2, yeah. And then the height is 19. So our surface area, how much area do we have in square centimeters to work with for the logo drawing here? Okay. Let's have the first 3 rows. You guys please figure out 2 times pi times 3.1 squared. These rows over here, please figure out 2 times 3.1, 4 times 3.1 times 19. When you're ready, go ahead and shout it out for me, please. Okay, so you guys, that's for the second one, right? Yeah. So we have a 369.9. In the first couple of rows, can you give me anything for the first one? Say again, please. 60.3? 60.3. Do we all agree on the first row over there, please? Okay, so our surface area total Let's add those two together. Tell me what you get. 430.2 centimeters squared. That's how many square centimeters you have as an artist to put all your information onto that tall Arizona iced tea can. So we are finding surface areas for cylinders. What do you guys think? Pretty good? Okay, so this little formula here, this is the one that we're going to use that's on our toolkit. So we want to use the second half of that formula. It's easier than the first part, okay? I drew a little picture for you on the right-hand side so you can check to see, make sure you've got it right. Any last questions or thoughts? No, okay, let me